So I changed actually the subject of my thesis completely, and against the will of my supervisor. So that is a nice message maybe to PhDs nowadays.
Yeah, that's what they say, right? All the good scientists are rebels. So you're definitely a bit of a rebel in your PhD.
You need to be a bit of a rebel. Yeah.
So just a little bit of background for the perhaps not so geologically inclined is that Fritz was tasked to reconstruct the geological history of southern Italy. And the rock layers displayed a very regular, nice pattern, which obviously we now know was caused by orbital cycles, Milankovitch cycles. Was this a big topic of study during this time, or is it really your own personal interest that started this exploration?
So it was an interesting time because they started to study the Milankovitch forcing of the ice ages because they recovered these piston cores from the bottom of the ocean since the 1950s. Okay. So that was underway, but that was only about the Pleistocene ice ages of the last 1 million years. And so then we start to study more the cycles in older parts and not only related to the ice ages like the subpropels. Yeah. And so I think they started before, but the way we looked at it, so we had this excellent team with magnetostratigraphy from the Paleomagnetic Lab, and we had the Biostratigraphy. And so then we started to create what is now known as the Astronomical Time Scale. Yeah, so to explain that a little bit, you have these very nice cycles that you see in the fields, that you see in the parameters that you measure. And then you can also calculate curves, what we call target curves, from astronomical solutions of the solar system. And these curves are then of the precession, obliquity, and eccentricity cycles. So we can correlate the cycles that we see in the field to these astronomical cycles, and then you get astronomical ages. So these are numerical absolute ages. So that was really a revolution. Yeah.